Okay, section 1.3 is data collection and experimental design. So we're going to be talking about statistical studies in this section. So the goal of any statistical study is to collect data. Usually it's from a sample, and we're going to use that to help us make a decision, typically for the population. So the steps for designing a statistical study, the first step is identifying the variable and the population. Second step, developing a plan for collecting the data, which is typically going to be a sample, and we're going to get to that in a little bit. Step 3 is actually collecting the data. Step 4 would be describing the data using statistical techniques. Step 5, interpret data and making inferences. So that was the inferential statistics from section 1.1. And then anytime we're using a sample to draw conclusions based on a population, there's always going to be errors, so we need to identify those errors. Okay, so there's going to be two types of statistical studies. The first one is going to be an observational study. This is just observing or measuring characteristics of interest, but not changing existing conditions. Okay, so that one's key for this one. We're just observing, so not changing conditions. The next one is experiments. So experiments is when a treatment is applied to a group, and then no treatment is applied to another group. So the group where no treatment is applied to, that's called the control group. So control group. And occasionally we have another group where we'll give them a fake treatment, and that fake treatment is called a placebo. Okay, so that's an experiment. So let's do an example. So determine whether the following studies are observational studies or experiments. So the first one, we have researchers are studying the effect of vitamin D3. 70 patients receive 4,000 IU of vitamin D3 and the rest of the patients receive nothing. So we want to know if this is an experiment or an observational study. So this is probably pretty obviously an experiment. So we are administering a drug, and we also have a control group here that's receiving nothing. And we have B here. So scientists follow several groups of wolves to determine on average how much meat they consume on a yearly basis. So there's no change being made. They're just observing and measuring. So this is an observational study. Okay, so pretty easy to determine the difference between those two. So a couple more definitions here. So the next thing we have is the placebo effect. So the placebo effect is going to occur when a subject reacts favorably to a fake treatment. So this actually, we don't want this to happen in experiments. So to help control this, we use a method called blinding. So blinding is a technique where subjects don't know if they're receiving the actual treatment or a placebo. The next thing, we have the 4 properties that make up a well-designed experiment. So if you have if you're doing an experiment, you should have these 4 properties to make sure that it's well designed. So the first one is that it's a double-blind experiment. So we just mentioned the definition of blinding. So double blinding is when neither the subject nor the experimenter knows who is receiving which treatment. So it knows who is receiving the placebo or the treatment. Okay, so that's a double-blind experiment. Double-blind, so 2, so subject and the experimenter, neither of them know who's receiving the placebo or the treatment. Obviously, it's on record who is receiving which. And then the next thing is randomization. So this is probably pretty obvious. We need to randomly assign subjects to the different treatment groups. we need the experiment to be random. We need the subjects to be randomly assigned. The third thing is a large sample size. This kind of speaks for itself here. There is a large number of subjects. The larger the better. And the last thing is replication. So replication is the repetition, the ability to repeat an experiment under similar conditions. Okay, so repetition of an experiment under similar conditions. So you do an experiment, you get certain results. If your results are most likely true, that experiment should be able to be repeated under the same conditions. Okay, so those are the 4 properties of a well-designed experiment. Okay, so for the next thing, we'll go over how we're actually going to be acquiring these random samples. These aren't the only ways, but these are the main, kind of the main 4 ways we're going to be doing it. So for a random sample, a definition of a random sample is every member in a population. So every member in a population has an equal chance of being selected. If that's the case, then it will be a random sample. So the 4 ways we're going to be doing it here are going to be a simple random sample, which we abbreviate with SRS. Then we have a stratified sample, a cluster sample, and a systematic sample. So let's go through and do one of each. So for the first one, for a simple random sample, so a simple random sample, this is going to be when every possible sample of the same size has an equal chance of being selected. Okay, so the way that we do this for how to collect a SRS, the first thing we're going to do is we're going to assign numbers. So we're going to assign numbers to each member in the population. So they're all going to get numbered. And the second step we're going to do is we're going to use a random number table. So usually we would let the computers do this for us. So what we'll see in the example here, when we assign numbers to members in the population and we're going through a random number table and picking out those numbers in order, we're going to get numbers that are not in our interval. So what we have to do is we're going to have to ignore those numbers. So we're going to ignore numbers not in the numbers you assigned, not in the interval of numbers assigned. Okay, so let's do an example to see what I mean here. So for the first example, let's say there's 731 students in a school. Using the SRS method, the simple random sample method, let's form a sample of 8 students. So 8 students, we want 8 out of that 731 using the following string of numbers. Okay, so let's see here. So what we're going to do is we're going to assign the numbers 1 to 731 to each one of the students. The tricky thing here is since 731 is a 3-digit number, instead of using the number 1, we're going to use 001. So 731, 3-digit number, so we need our number 1 to also be a 3-digit number. So we assign the numbers 001 to 731 to the students. So what we're going to do is we are going to start at the beginning of this random string of numbers here, and we're going to read off the numbers in groups of 3. Okay, so the first one is going to be 926. So 926 is not in our interval of numbers that we assigned, so we actually have to ignore it. The next number is 307. So you can probably see these spaces between these groups of 5 numbers. They're only there to help you visually. They don't actually mean anything. So 307 is the next one. So these are going to be the students that we're grabbing. So the students in the sample. The first one that we're grabbing for the sample is 307, student number 307, whoever that is. Okay, the next one is going to be student 824. So once again, that is not in our interval from 1 to 731. So the next one is 019. So that is in our interval. So 019. And the next one is 267, which is in the interval. The next one, 954, which is not in the interval. 575, which is. 349, which also is in there. 723, that is in the sample. And 894, which is not. 377, which is. So we need one more. And we do get the last one next, which is 087, so 087. Okay, so all of these numbers represent students that we just assign the number to. And these are our 8 students that we got for the sample. Okay, so let's do the next one. That's SRS. So the next one is a what we call a stratified sample. So a stratified sample, we're going to use this. We're going to use this when we want to have members from each segment from a population. So I'm going to put little quotes around segment because we'll see what this means in a second. So from each segment from a population. Okay, so let's see how we collect this stratified sample. So what we're going to do is we're going to divide the sample, rather divide the population into subsets. We're going to call these subsets strata. So stratified sample, these subsets, these groups are called strata that contain similar characteristics. Okay, so we're the ones chopping up the population into different subsets called strata. Each strata should contain a similar characteristic, so we chose how to do that. All right, and then what we're going to do, we're going to have all these different strata, all these different subsets. We're going to perform the simple random sample, which is what we just did, in each strata. So we're going to do that in each strata to obtain the desired amount for the sample. Okay, so let's do an example so it makes a little bit more sense here. So for example, let's say that we want data on people's spending habits in New York State. So using the stratified sample method, we wish to divide people into different strata. So one method to do this is to divide the population into similar spending habits by doing their age group. Okay, so the original question here is we want spending habits of people in all of New York. So we want to kind of chop it up in where people have similar characteristics. So we said, well, okay, let's chop them up into each age group. So the reason we did this is because now we know that each age group is going to be represented the same amount of times in our sample. Okay, that's not the only way to do it, but this is just one example for it. Okay, so let's say we have these little age groups. I'll have an age group be 0 to 12. Another one be 13 to 21. And then 22 to 35. 36 to 50. 51 to 65, and then greater than 65, so 65 plus. Okay, so what we would do here is we would, not going to obviously do it here, but just kind of mention how we do it. We would perform an SRS in each age group. So these age groups are called the strata. These are the different strata. So let's say, I'll write this down. So let's say we want 60 in the sample. That means we would perform SRS in each group. And we would do this to obtain 10 individuals from each age group. So this ensures that each age group is represented the same. So we would get 10 from 0 to 12, 10 from 13 to 21, and so on. That would give us our total of 60. Okay, so that is a stratified sample. So the next one is a cluster sample. So a cluster sample, it's going to seem kind of similar at first to a stratified sample because we're going to be dealing with subgroups again. Kind of the difference here is we're going to use this when the population falls into naturally occurring subgroups. Okay, so this is called a cluster sample. So the way that we do this is we're going to divide the population into groups, which once again are just kind of naturally occurring. So these groups are called clusters this time. And what we're going to do, depending on how many individuals or members we want for the sample, we're going to select one or more clusters for the sample. So we divide the population into the naturally occurring subgroups, which we call clusters, and then we're going to choose one or more of those clusters for our sample, depending on how many individuals we want for the sample. Okay, so let's do an example. So just like that previous example, we're going to do the same thing. So suppose we want data on people's spending habits in New York State. So we're going to collect these individuals for a sample for their spending habits, except this time we're going to use the cluster method. So using this cluster sample method, we want to use naturally occurring subgroups. So one way to do this is to divide the state into counties. So these are our naturally occurring subgroups to ensure we created those counties, but they're there for us to kind of take advantage of to create our sample. So we're going to divide the state into counties. Each county is going to be a cluster, and then we're going to choose one or more counties as our sample. Okay, so I'm not going to go through and actually do that, but that's how we would do that. So that one's actually pretty easy. We take advantage of how the population's already naturally divided, and then we just select one or more of those clusters depending on how many we want. Okay, and the last one is a systematic sample. So a systematic sample, just like the name suggests here, there's kind of like a system in place for how we're doing it. We're going to be choosing members for our sample at regular intervals. Okay, so which we'll see in a second, I'll be writing this down, but we'll either be choosing we'll be choosing every kth individual, like every 5th individual after they're in order, every 20th individual, every 50th individual. So let's see how we do this. So how to collect a systematic sample. So the first part is each member is assigned a number. So each member is assigned a number. And the next thing is that the members are ordered. They're ordered and they are selected at these regular intervals. So every kth, oops, that was an ugly K. Every kth member is selected. So then the question is, how do we choose what that K is? How do we choose what every kth member is? So the way that we do that is we just do it, we just divide. We just say that K is the number in the total population divided by the desired sample size. Desired sample size. And I'll put a little note, since we're dividing, we might not get a whole number. So we may need to round to the nearest whole number. Okay, so when we divide this, that will give us our every kth member. So let's do an example here. So let's say we wish to choose 20 houses from a street with 100 houses on it using the systematic sample method. Okay, so let's say we want to find our K. Let me move this up a little bit. So our K here is going to be the number in the population, which is 100. We want a sample size of 20. So we're going to do 100 divided by 20, which is going to give us 5. So what this means is we have houses on a street. We are going to choose every 5th house. Okay, so let's say we had houses. Let's say these are the houses. X's are just representing some houses here. So if we chose the first one, that's the first one we're choosing. So then we would do 1, 2, 3, 4, 5, choose that one. 1, 2, 3, 4, 5, choose that one, and so on. So we're choosing every 5th house. So the only thing that we have to keep in mind here is if there's a pattern, which is this note down at the bottom, if there's a pattern in the order that these members are in or these individuals are in, then this will completely ruin the randomization because we're choosing these at a pattern in a pattern. So if there already is a pattern, then it won't be random. So that's the only thing to keep in mind for this. Okay, so for the last thing, those are the 4 ways that we can collect random samples. So not the only ways, but those are the 4 main ways here. So there's also bad sampling techniques. So the 2 main bad sampling examples here are convenience samples and bias samples. So they kind of tell you, once again, in their names, what they are. So for a convenience sample is when the members in a population are just easy to access. So that might not be very random if they're just easy to access. It just means the person in charge of this is being lazy. So for example, if you're doing a survey and you're asking your friends, that would be convenience because you can just call them, text them, and get their opinion for a survey, and it wouldn't necessarily be very random. They would be your friends. And the next one is the bias sample. So a bias sample is when some members of a population are purposely left out of the sample or included in the sample on purpose. So for example, the first thing I always think of when I think of bias sampling is presidential approval ratings. So if you go to the different news sites for approval ratings for a president, if it was Fox News and we have a Republican president, they would probably have that the approval ratings are high. And then if we went to CNN for a Republican president, they might have it not so high. And then vice versa for a Democrat president. Okay, so those are just 2 examples of bad sampling. So obviously those are things that need to be considered. Okay, so that is it for section 1.3.